In 2020, astronomers detected something impossible. Not on Mars, not on Europa, not in some distant exoplanet system, but in the clouds of Venus, Earth's closest planetary neighbor. A chemical signature that, on Earth, is produced by only one thing: living organisms. For decades, scientists said Venus was dead. A hellscape of crushing pressure, sulfuric acid rain, and temperatures hot enough to melt lead. A cautionary tale of what happens when a planet loses control of its climate. But what if we were wrong? What if Venus has been keeping the greatest secret in astronomy hidden in plain sight, suspended in those deadly clouds? And if life can exist there, in the most impossible place imaginable, then we've been asking the wrong question our entire time searching the universe. We're not looking for life where we expect to find it. We should be looking everywhere else. Hello everyone, welcome back to my channel Orbit Unknown. Today we are fascinating the very interesting story, the clouds that changed everything. Why Venus might have alien life, Part 2. The discovery September 14th, 2020. That's when the news broke. A team of international researchers led by Jane Greaves published findings in Nature Astronomy that would ripple through the scientific community. They had detected phosphine, a gas made of phosphorus and hydrogen, in Venus's upper atmosphere. To understand why this matters, you need to understand phosphine. On Earth, phosphine is produced in three ways. In laboratories, through industrial processes. In some rocks, through natural chemical reactions deep underground. And in living organisms, microbes, bacteria, single-celled creatures that release phosphine as a biological byproduct. The detection came from data gathered by the James Clerk Maxwell Telescope in Hawaii and confirmed by the Atacama Large Millimeter Array in Chile. These aren't amateur observations. These are some of the most powerful instruments on Earth, capable of detecting the faintest whispers of chemistry in the cosmos. But here's where it gets complicated and controversial. The amount of phosphine detected wasn't overwhelming. It was subtle, ambiguous, the kind of data that scientists argue about for years. Some said it was real. Others said it was a measurement error. Still others claimed it could be explained by non-biological chemistry we simply don't understand yet. The debate was fierce, immediate, personal. Because if they were right, if phosphine really does indicate life on Venus, then everything changes. Part 3. Why Venus seemed impossible to understand. Why this discovery shook the scientific world. You need to understand Venus itself. Our sister planet. Our cosmic doppelganger that took the wrong evolutionary path. Venus is almost exactly the same size as Earth. It orbits closer to the Sun. It has an atmosphere. It has a surface. By all rights, it should be a second home. A twin world. But instead, it became something unimaginable. The surface temperature reaches 900 degrees Fahrenheit. That's hot enough to melt lead. Hot enough that spacecraft sent by humanity lasted only minutes before their instruments fried and their structures collapsed. The atmospheric pressure is 92 times greater than Earth's. Imagine being at the bottom of the ocean. Now imagine being 900 times deeper. That's Venus's surface. And the clouds? They're not made of water vapor like Earth's clouds. They're made of sulfuric acid, liquid sulfuric acid. The clouds rain acid. Constantly. Eternally. Year after year, century after century. The rain falls upward, never reaching the ground because it evaporates in the heat. Venus is a chemical nightmare. A planetary hellscape that seems to reject any possibility of life. And yet, there's one place where conditions might, just might, be different. High in Venus's atmosphere, roughly 53 to 61 kilometers above the surface, temperatures range from 50 to 80 degrees Celsius. That's hot, yes, but survivable, potentially habitable. In those clouds, the pressure is closer to Earth's sea level. And in those clouds, Earth's conditions and Venus's alien chemistry could theoretically coexist. That's where the phosphine was detected. That's where life, if it exists on Venus, would have to live. Part 4. The implications if that phosphine detection is real, if it genuinely indicates biological activity, then we need to fundamentally rethink where life can exist in the universe. For centuries, we've had a narrow definition of habitability. We've looked for water. We've looked for temperate climates. We've looked for places that seem familiar to Earth. We've called them habitable zones, Goldilocks planets, places that are just right. But what if life doesn't need just right? What if life is a more versatile force than we've given it credit for? What if the universe is full of extremophiles? Organisms that don't just survive in harsh conditions, they thrive in them? If Venus has life, then life on Europa, with its ice-covered oceans, becomes not just possible but probable. Life in the frozen methane lakes of Titan becomes something we should seriously explore. Life in subsurface oceans on distant exoplanets becomes not science fiction, but genuine scientific inquiry. The implications are staggering, not just for how we search for life, but for how many civilizations might exist out there in the cosmos, invisible to us because we're looking in the wrong places with the wrong assumptions. And there's something else, something more disturbing. Venus might be a warning. It might show us what happens when a habitable world spirals out of control, when a runaway greenhouse effect takes hold, when a planet loses its magnetic field. Venus might be Earth's future if we're not careful. But it might also be so much more than that. Part 5. The evidence. The phosphine detection came from two of the world's most advanced telescopes. The James Clerk Maxwell Telescope and 15-meter sub-millimeter telescope in Hawaii that's been scanning the skies since 1987. And the Atacama Large Millimeter Array in Chile. 64 massive radio dishes arranged across the Atacama Desert, one of the most sensitive astronomical instruments ever built. Both detected the same signature, the same chemical fingerprint. In Venus's upper atmosphere, at multiple altitudes, the phosphine was there. The data wasn't ambiguous in that sense. The telescopes saw what they saw. But here's where it gets tricky. Phosphine is absorbed by light, destroyed by ultraviolet radiation from the sun. On Venus, at the altitudes where it was detected, phosphine shouldn't last more than a few hours in the sunlight. And yet, astronomers detected concentrations suggesting a constant source, a steady production. That means something, or someone, must be making it continuously, replenishing it as it breaks down. On Earth, phosphine is created by living things, microbes in soil and oceans, microbes in the guts of animals. It's a biological waste product, a byproduct of anaerobic metabolism, the kind of chemistry that life uses when there's no oxygen available. But phosphine can also be produced through chemical reactions we don't fully understand. It can form in the clouds of gas giants. It can form under extreme pressure and temperature. It can form through chemistry we haven't even discovered yet. And that's where the controversy crystallizes. The question becomes, is this biological phosphine or chemical phosphine? The researchers who found it believe it's biological. The analysis, they say, shows concentrations that are hard to explain through non-biological chemistry. They point to models suggesting that Venusian cloud chemistry, as far as we understand it, shouldn't produce this much phosphine. But other scientists remain skeptical. They've published alternative explanations. They've suggested mineral reactions we haven't considered. They've proposed undiscovered chemical pathways that could create phosphine in Venus's clouds through completely natural, non-biological means. The truth is, we don't know Venus's chemistry well enough to rule either possibility out. Part 6. The mystery deepens since that 2020 discovery. The hunt for truth has intensified. More observations, more data, more arguments about what it all means. In 2021, another research team, led by astronomers at the University of Texas, reanalyzed the original data using different methods. They found the phosphine detection was real. They confirmed it. But they also found something unexpected. The distribution of phosphine in Venus's atmosphere was stranger than anyone thought. It wasn't uniformly distributed. It was concentrated in patches, in certain areas of the cloud layer, which is more consistent with a biological process, life clusters in certain zones where conditions are right, than with a chemical process that would be spread evenly across the planet. That was alarming, exciting, deeply troubling, because if life is concentrated in certain cloud layers, that suggests adaptation. That suggests organization. That suggests biological complexity. Then came 2022. New telescopic observations. This time from the Sophia Aircraft Observatory, a Boeing 747 converted into a flying telescope that can observe at infrared wavelengths. The results were inconclusive. The Sophia data didn't clearly confirm the phosphine detection. It didn't clearly deny it either. The scientific community split. Some researchers said Sophia's failure to detect phosphine was proof it wasn't there. it was a false signal all along. Others said Sophia's instruments weren't sensitive enough, and the absence of confirmation wasn't proof of absence. The mystery deepened. The stakes rose higher. And then, in 2023, yet another team published findings suggesting that phosphine might indeed be chemically produced in Venus's clouds through reactions we'd overlooked. They pointed to specific chemical pathways that could explain the detection without requiring life. Science is a process of elimination, of hypothesis and testing, of arguments and counter-arguments until consensus forms. But in this case, Venus isn't cooperating. Every answer generates new questions. Every explanation spawns new mysteries. Part 7. What's at stake if life exists on Venus? Even microbial life floating in those sulfuric acid clouds. It changes everything about our place in the universe. First, it means life is robust, adaptable, resilient beyond anything we've theorized. If Venus can support biology, then the habitable universe expands exponentially. Every harsh world becomes a potential home for some form of life. Every extreme environment becomes a laboratory for studying how life adapts. But there's another implication that's darker, more urgent, more immediate to our survival. Venus is what Earth could become. It wasn't always the hellscape we see today. Billions of years ago, Venus probably had liquid water. It probably had a thinner atmosphere. It might have been habitable, like Earth. But something went wrong. A runaway greenhouse effect, a loss of magnetic protection, an accumulation of carbon dioxide in the atmosphere that trapped heat until the oceans evaporated. Once that process starts, it's nearly impossible to stop. The more heat, the more water evaporates. The more water vapor, a potent greenhouse gas, the hotter it gets. Positive feedback, a death spiral. Some scientists believe that's what's happening to Earth. Now, in real time, we're on the early stages of a Venusian transition. We haven't crossed the point of no return. Not yet, but we're closer than most people realize. Understanding Venus, understanding how it became what it is, understanding whether life can adapt to conditions like those, might teach us how to prevent becoming the next Venus. It's not just science anymore. It's survival. Part 8. The unanswered questions. The fundamental question remains unanswered. Is there life on Venus? We don't know. And we can't know. Not really. Without sending probes to collect samples, to study organisms directly, to answer definitively. But there are other questions just as profound. If life does exist in Venus's clouds, what is it? What kind of organism could possibly survive in sulfuric acid clouds? How would it obtain energy? How would it reproduce? How would it process chemistry so alien to anything we've discovered on Earth? We've found extremophiles on Earth, organisms that live in boiling hot springs, in frozen Antarctica, in pressurized deep-sea vents, in radioactive waste. But none of them live in sulfuric acid clouds. That's beyond anything we've witnessed. If Venusian life exists, it would represent a completely new form of biology. A second genesis. Proof that life on Earth isn't a cosmic accident, but a fundamental property of the universe itself. Another question, how did life get there? Did it evolve independently on Venus billions of years ago when conditions were different? Or did it travel from Earth, carried by meteorites or solar radiation? Could life actually be cosmic in origin, seeded throughout the solar system by processes we've never understood? And perhaps most haunting, if we can't detect life on Venus with certainty even when we think we might have found it, how many other worlds are we missing? How much life is out there that we simply don't have the instruments or the knowledge to recognize? Part 9. The future of Venus exploration. For decades, Venus was neglected. We focused on Mars, on the outer planets, on distant stars. Venus seemed too hostile, too dangerous, pointless. But that's changing. The phosphine mystery has reignited interest in our sister planet. Multiple space agencies are planning Venus missions. Real missions, with real budgets, with real intentions to finally understand what's happening there. NASA is developing the Veritas mission, Venus emissivity, radio science, in SAR, topography, and spectroscopy. It will map Venus's surface in unprecedented detail, looking for signs of recent volcanic activity, looking for clues about the planet's geological history. The European Space Agency is planning Envision, a comprehensive mission to study Venus's atmosphere, its surface, and its interior. Multiple instruments designed to peer through those deadly clouds and understand the dynamics of this alien world. But the most ambitious proposal comes from a concept called the habitability of Venusian clouds. Imagine sending a probe, not a lander that burns up in minutes, but an aerial platform. A floating station that would hover in Venus's upper atmosphere, in the narrow band where conditions are theoretically habitable. This platform would collect samples, analyze the chemistry, search for organic molecules, test for the presence of biosignatures, answer definitively whether life exists in those clouds. It's a staggering technical challenge. The extreme environment would destroy most conventional instruments. The sulfuric acid would corrode electronics. The pressure would crush delicate systems. But engineers are designing materials and methods that could withstand it. Some proposals suggest biological or chemical sensors, devices that could detect life's presence without needing to fully understand it. Detect changes in chemistry that only living processes create. Detect metabolism itself. Others propose something even more ambitious, collecting samples of cloud material and returning them to Earth for study. Definitively, conclusively, proving whether life exists on Venus or whether the phosphine detection was a false signal. But there's a catch. Planetary protection laws prevent us from potentially contaminating Venus with Earth life. We have to be extremely careful. Any samples brought back must be quarantined. Any probes sent must be sterilized. We can't risk spreading Earth organisms to Venus. Because if life doesn't exist there now, we don't want to be the ones that seeded it. Part 10. Final thoughts. We live on a planet where life thrives. Where billions of years ago, simple organisms emerged from chemistry and changed the world. We've assumed life is rare, precious, unique, that we should search the cosmos